Okay, so continuing where we picked up, the first thing we are going to do is we're going to set our working directory. And when we're in our studio, you can basically write a note to yourself if you put the hashtag symbol in front of whatever it is that you're writing. So R will not be in reading any of this or trying to run a command on this because it has this symbol here. So that's a really useful thing. So you can annotate basically whatever it is you're writing, so you know why you did it, or you know if there's anything specific about that particular code. So there's a couple ways that you can set the working directory. The easiest, I think, is if you go up to the top panel and then you go to session and then you set working directory and then you can choose the location. So for me, I put mine in the desktop, and there's my ROTO code. Yours should be empty, so don't worry about that. And then we'll click open. And so remember, this is where the script is, where you save basically the commands that you write, and then this is the console where it's actually running the command. So this means that the command of setting our working directory to this ROTO code folder was completed. You can also check that by doing the command get working directory. So when you're in the script up here, basically the way that you can run the command is just by clicking this button, or there's for a Mac it's command return basically, and I think it's just enter for a Windows computer. But so the output here tells me, and if there's a number, usually here, that's basically just telling you this is the output that happened in RStudio. So our location is Lauren desktop ROTO code, which is great. That's exactly what we were hoping for. So now we're going to kind of go through the steps that I talked about in the PowerPoint and just kind of get a little practice in. So first we're going to define variables, and we're going to set them to numeric data, so as a numeric data type. So we're going to define x, and we're going to set it equal to 25, and then we're going to do the same thing for y, and it's going to be equal to 10. So when we run these things, what we can see here, where it's our environment and our data, is that we now have these variables which are defined, and we can refer back to and see that they're actually set correctly. We can also see here that it ran the code, and if you wanted to check whether or not it actually ran it correctly, you can just type in the variable and then run, and then it will tell you the output. So if you try to do this and you don't capitalize the x and we try to run it, nothing's found. And this is because R is case sensitive, so whether you capitalize or not, and punctuation as well, those are all different types of variables. So it's really important to make sure that you are being consistent. And you can always check again by basically running this command, which is called printing. And yeah, printing is basically just getting R to tell you what the answer is to the command that you just asked. So like we talked about in the PowerPoint, we can do a lot of different math functions. So if I added, our variable x to itself, the output would be 50. If I multiplied x to itself, it would be 625. And if I took the square root of y, that's a good one, then it will tell us that as well. And so we can also create a character variable. So I'm just going to make the variable, which is my name, and I'm going to define it so it is equal to my actual name. And when you do a character variable, you have to have these quotations because that's the way that R understands that it's not a numeric data type. So if I run this, then we can see here I have a new variable, which is called Lauren, and it's important to note, and I mentioned this earlier, that you get to define these variables. So I used x above, but I can also define my name as x. It really is totally up to you. And again, I can print both of those things, and both of them should come out with the name Lauren, which is great. And now we're going to do a little example where we compare x and y and then get a logical output. So I ran these two codes again because what's important to note is if you use the same variable twice, R will just erase and like copy over basically. It will write over whatever the previous value was. So when I set Lauren, or I defined x to be Lauren, that meant that the value I had up here of 25 no longer existed. So since I want to be doing a comparison between two numeric data types, I ran this code again. So if we are going to be comparing y and x, and we're asking R to tell us is y greater than x, what would the answer be? We hope that it will come out with false, right? So basically, we're defining z as that output. So the answer to whether or not y is greater than x is the variable z. So when we run that, and then we ask R to tell us what the answer is, what is z, we see the answer is false, which is great. And if you don't remember, or like you just want to check, what kind of data type your variable is, then you can run this command, which is called class, and then basically you just put inside of the parentheses the variable that you want to know what type of data it is. So if I run it for z, my name, and x, which I just defined to be 25, what kind of answers should I get before I run it? Z would be a logical data type, and then my name would be character, and x should be numeric. Right? And so that's exactly what we see. So now we're going to create a vector. And so to create a vector, you have this command C, which is for concatenate, but you can think of it as create. So we're going to make vector 1, and we're going to do it by having the command C, and then inside of the parentheses, this is our string of variables. So you can just write out numbers. If you have variables that are already defined, you can use those as well. And basically when we run it, and then we print, so we ask R to tell us what the answer is, it places in those values that we had set for x and y, and also combines them with the other numbers that we included. So one thing that is important to note is that, remember, vectors have to be of the same data type. So if I make a vector, let's make it vector name, and I, instead of y, write, and let's make sure if I capitalize or not, okay, my name, oops, right, and we run this, and then we ask for the class of vector name, right, it's character. And so if we print it, oops, we see that because Lauren is a character data type, all the other numeric data types got converted into character. And so that's important to remember, because you don't want all of your numbers getting converted into characters, because then you can't do math functions on them. So make sure that whatever you're putting into your vector, it is numeric, if you're going to be doing any kind of math. You can make vectors that are all character as well, or vectors that are all logical as well, and then you can use that to make a matrix. So let's go back to our vector 1, which was just numeric, and do some math on it. So we can sort. So now everything is in ascending order. We can find the mean, the sum, the matrix, the standard deviation, and all of these commands will be given in the PowerPoint, and I also have links so you can look at basically all of the different kind of math functions that you can do with each of the different data structures. So let's create a second vector, which we're just going to call vector 2. And another way that you can make a vector, if you don't if you're just kind of wanting to generate one quickly, is you can use basically semicolons to tell R to make it from 1 to 5. So it includes all the numbers in between. So I'm going to run this, and then we're going to print it, and you'll see that now we have a vector that goes from 1 to 5, including, you know, everything in between. So we have two vectors, right? We have our vector 1, which we can just print it again. The cool thing is that once you've written this stuff, you can just run it, and you know, it obviously saves, you know, the variable and the data and the values for you. So it's very easy to like keep track of what things are what. So we have our vector 1 and our vector 2. So these are the outputs down here. Okay. And now we're going to use those two, and we're going to combine them in order to make a matrix. So I'm going to show you two different ways to make a matrix. So the first way is going to be doing something similar to what we did for vector 2. So we're going to say make a matrix using matrix, and then inside of the parentheses, that matrix should be going from 1 to 10, and the first value refers to how many rows, and then the second is how many columns. So we're going to run that, and I'll go down here and I will print it, and we see matrix 1, mat 1, has our 5 columns and our 2 rows. So we can also, like I showed, or like I was saying in the PowerPoint, combine vectors together. So when we use a different command, which is called cbind, we're going to be combining by columns. There's also rbind, which combines vectors by rows. So when we make matrix 2, and then we print matrix 2, basically what we see is that we combined vector 1 and vector 2, and they're lined up by column. So that's what that is referring to. If we change this to R and 3, let's see. Okay, and then we need to print it so we can know what the output is. Then we see, instead of having it lined up, you know, in columns, it's now lined up in rows. So I'm going to show you something else. So we can also get the dimensions as well. So this is basically telling us in terms of the column names, and again, this is for that first vector that we used, where we combined each of the vectors by column. So each column has each column name is basically a variable, which means that the matrix is made up of vector 1 and vector 2. We can also create a subset of a matrix. So in order to do that, basically, so this is like, if I don't want to look at all the columns, say I only want to look at, you know, the first 3 columns, then I can do that. So I can make a new matrix, which I'm just going to call M1. It's shorter than mat1, right? So M1 is going to be, we're going to use square brackets to tell R to do something to this matrix. We want it to do a command to this matrix, and that is making a subset of it. And then just like it was before, the first value would be if we wanted to say, you know, how many rows we wanted to include. If you want to include all of them, then you don't have to say anything. And then the second one is for columns. So we only want the first 3 columns. I could also write 1 to 2, you know, if I wanted to, but I don't have to. Okay, and when we look at it, we now see that there's only 3